So concentration, we can start with the liquid solution as of now as per the discussion, and chemical kinetics also we can see later on, right? Just a second. The solutions are basically homogeneous mixtures, right? That we have studied in junior classes also. Of two or more components. And what the solution which is having two components known as, can you tell me? Aisha and Marwa, can you tell me what is the solution with that which is having two components?
Binary solution.
Yeah, binary solution. So binary solution is the solution having two components, right? Exactly. Okay. And two components, one is actually called known as solvent and another one is known as solute, right? So what's the difference between the solute and solvent? Yeah, you can tell what is solute.
Solute is something that it gets dissolves in the solvent, and solvent is which makes the solute dissolve in itself.
Yeah, exactly. So solute is a substance which is being dissolved, right? And the substance which is used for dissolution is known as solvent. In order to understand the properties of a solution, we need to know how much solvent is there and how much solute is there. Okay. And there can be various ways to classify this solution. Actually, the solution, binary solution can be solid and liquid solution. In which one the solute is solid and the solvent is liquid, right? It can be liquid solution, or it can be gas dissolved in liquid. This chapter deals with a liquid solution, means there are solid solutions also, you know. For example, alloys. Alloys are solid solutions, solid mixed into one another solid. Okay. So in this chapter, we are mostly targeting liquid solutions. These are binary solutions. We know that. Okay. And liquid solution, one component is solute, as you very correctly said. Another component is the solvent. Solvent is generally present in large quantity. It is the medium for the dissolution of the solute. I hope it is clear, right? Now, how to express the relative amount of solute and solvent? There are two ways. One is the qualitative, another is the quantitative way to express the concentration. So what are the qualitative ways that all of us use in our daily life, and quantitative ways to express the concentration? Can you tell me? Qualitative ways means we are not dealing with the numbers. Is it clear? We are actually not expressing the concentration in terms of numbers, just orally we are telling. So Aisha and Marwa, can you tell me what are the qualitative ways by which you can express the concentration? All of us know that whether a solution is dilute or it could be concentrated. Is it clear or not?
Yes, sir.
And these are not of much use. Normally we use them in our daily life. But in this chapter of liquid solution, we need some concentration numerical because we need to calculate numerically. So what are the numerical concentration terms? Can you tell me, Aisha? What are the concentration terms which are used numerically? Yes.
Mass percentage,
Yes, mass percentage.
volume percentage, and mass by volume.
Yeah, mass percentage. W by W percent. Right.
Yes.
Okay. And
Volume by
mass,
volume.
mass by volume and volume by volume percentage. So both of you are preparing for NEET or JEE or for both? Or for CBSE? Tell me.
For CBSE currently.
Okay, as of now, yeah, that's because CBSE now, a lot of questions are being exactly being taken for CBS from NCRT. Okay, so that is good. Mass by volume percentage and volume by volume percentage. Okay. Volume by volume percentage, and it is in short, it is written as V by V percent. Right.
Yes.
And what are the other terms, Marwa? Can you tell me? Other concentration terms, if you know.
Is it molarity?
Yeah, molarity.
Molality
Yes, molality.
and mass percentage? No.
Yeah, that is already being covered. Aisha, would you like to add more?
So parts per million, mass of solute
Yeah,
upon mass of
ppm,
solution.
ppm, and there is one more term which uses moles. Marwa, can you recall which has moles in the numerator as well as in the denominator? That is mole fraction. Okay.
Okay.
Mole fraction is represented by a symbol which looks like X, but it is not X, it is chi. Okay. ppm, it is parts per million. There is a normality also. Normally we don't get into that much detail. It is because you might have used it in redox reactions. Okay. So let me, because these are some of the basic terms, you know that. Let me take a very important one, which will be useful for all of us. Okay, and that is molarity. Is it clear? Molarity. So what is the definition of molarity?
It's the moles of solute upon the volume of solution and liters.
Yes, exactly. So how many moles of a solute are present in 1 liter? 1 liter, we know that 1 liter water bottle, we know that. Okay. So how many moles of solute are dissolved in 1 liter of solution? So molarity, it is represented by capital M, and as the definition says, it is the number of moles of solute dissolved in 1 liter of solution. That is molarity. And it is written, you might have seen, it is written 5 molar NaOH. What it means? 5 molar NaOH means what? Means molarity is 5. Okay, so 5 moles of NaOH are present in 1 liter of solution. Got it? This is the definition and this is the representation. What is the formula? As you said the formula very correctly. The formula for molarity, Marwa and Ayesha, that is molarity equal to number of moles of solute divided by volume of the complete solution in liters. So what is the unit of molarity?
Mole by liter.
Yeah, mole per liter. Right. Because the numerator has unit mole and the denominator has unit liters. Right. So Marwa, is it clear?
Yes,
Mole per
sir.
liter. Okay, it is a unit of molarity. In the denominator, we have the volume of complete solution. Okay. Suppose if the volume is given in ml, then what should we do?
Convert.
Multiply it with 1000.
Yeah. Suppose if the volume is in ml, if it is given in ml can be converted in liters if you divide it by 1000. Okay, this 1000 will, if you um, reciprocate, it will come in the numerator. So number of moles into 1000 divided by volume in ml. So that I hope is clear to you. Okay. Can you tell me one drawback of molarity? Drawback. What is the disadvantage? It has a lot of advantage. We are going to use it everywhere, but we should know there is one disadvantage of polarity. What it is? Both, can you tell me, Ayesha and Marwa?
Because it is dependent on temperature.
And the hint is it has volume in the denominator, volume of the solution. Yeah. So because you have volume in the solution, that volume can, in as we know that when you have temperature increase, the volume expands, and when temperature is decrease, the volume contracts. But the number of moles of solute, they will remain same. Got it? So number
Yes,
of
sir.
solute are same, but the volume can change with temperature. Okay. So drawback of molarity is, or the disadvantage of using molarity is, it can change with temperature. Is it clear to both of you?
Yes, sir.
Molarity can change with temperature. It is because the volume of the solution can change with temperature. So I hope this is clear to both of you. Okay. So molarity is temperature dependent, and in this chapter, normally in the properties, qualitative properties which we are going to study, we are not going to use molarity because it is dependent on temperature and it can change. So we are not going to use the concentration term which can change. So we are going to use, wherever the temperature is changing, we are not using molarity. We are going to use molality, that is represented by small m. Okay. So this is something about the molarity. And suppose I can write it in more detail, the formula, but you need to remember this formula, that you need to put the moles on the numerator and the volume of the solution in liters in the denominator. And if suppose B is the solute, mass of the solute is mb, molar mass of the solute is capital M. Okay. And A is the solvent. You are going to see the molarity equal to number of moles of solute. Number of moles of solute is given mass by molar mass, MB or WB. It is written as WB also some places. That is a mass. Different books follow different convention. WB upon molar mass, right? These are the moles divided by the volume of the solution in liters. If it is in ml, multiplied by 1000. Okay, so let's start with the numericals. For example, if I put 5 gram NaOH is present in 250 ml of solution. So Aisha and Marwa, tell me what is the molarity of NaOH?
It should be written as 5 grams upon 250. 250 should be multiplied with 1000 so that it can be converted into liters.
But is this the mole
Sorry,
or is
First
it the
we
mass?
have to calculate the mole, so it will be 5 upon the molar mass
Yeah.
of NaOH.
Yeah. So molar mass of NaOH, we know that Na plus oxygen plus H is there, and this is 23. This will be given to you, okay? And this is 16, and this is 1. So 23 plus 16 plus 1 is 40 grams per mole. That is a molar mass, means it is a mass of 1 mole of NaOH. That is 40. Means 40 gram will make 1 mole. So number of moles you can find out. You can do it separately, okay? Because it is going to, even if you make some mistake, you will be able to make out. Okay, number of mole is given mass by molar mass. Okay, given mass is 5 grams and the molar mass is 40 gram per mole. Okay, so this is 5 and 8, 1 by 8 moles. Let it remain in the fraction only because we need to solve it further, right? And volume is how much? Volume is
250 ml.
250 ml, very correct. So in liters, it is going to be how much? You can divide it by 1000.
0.25.
Yeah, 0.25 liters. So one fourth of a liter. Okay, 250 ml, 250, 250. Okay, yeah, that is 250 by 1000 divided by 1000 liter. Or if you're directly putting Marwa in the equation, you can put the 1000 in the numerator, right? So it is 0.25 liters, right? So molarity is, what is the value of molarity? Can you tell me now?
1 by 8 upon 0.25.
Yeah, 1 by 8 into 0.25. Okay, let's multiply it. How much is it going to be? 25.25 is 1/4. Okay, so if I multiply it, it is going to be right 2. Is it clear or not?
Yes, sir.
1 by 2. Okay, 1 by 2 is half, 0.5 molar. Is it clear or not? Got it?
Yes, sir.
Marwa, is it clear?
Yes, sir.
So we are having, so it is also written, sometimes the student get confused, m by 2. The student sometimes get confused what is m by 2. Okay. Actually m by 2 is half molar or 0.5 molarity. Means what it means, this is 250 ml. If you take 1 liter of the solution, half mole is present. Got it?
Yes, sir.
So if I ask you the same thing, how many moles of NaOH are present in 2 liters of this solution? The next part of the question. Are present in 2 liters of the above solution. The next part. So as of now, I have taken just 250 ml. If this same solution is taken in large quantity, 2 liters, so how many moles will be there of NaOH? What will be the answer? Molarity is same. Above solution has a molarity of that we calculated, okay, 0.5 molar. Is it clear? So just try to figure
Yes.
out. Just try to figure out a little bit how many moles are there if the volume is taken as 2 liters. Question I hope is clear to both of you. So how we are going to attempt it? Any idea? Ayesha and Marwan, tell me.
We can like moles will be equal to molarity times the volume.
Yeah, exactly. So we are going to use the same formula, molarity equal to
Yeah, we rearranged formula.
number of moles by volume of the solution. And volume should be in liters. Okay. So what values are we going to put, Marwa, in molarity? That is same. They are taken from the above part, right?
0.5.
0.5 m. And number of moles, how
We
many
have
moles?
to find out.
We have to find out n. And volume now it is changed, it is taken 2 liters.
Yes.
So number of moles we can find out by cross multiplying 0.5 into 2. That is 1 mole. Okay. So this I hope is clear, very simple. So just molarity is moles by volume in liters. And if you want, just remember one formula and all your questions will be solved. Moles you can find out separately, mass, given mass by molar mass. Volume must be in liters. If it is in ml, you can use this formula, n into volume in ml. That need to be divided by 1000, so that 1000 will come in the numerator. This is going to be the formula. Okay. Next question is, what happens if you add more water into a solution? What happens to its molarity? Suppose a sugar solution is there, okay, and what happens to it? We can also find the molarity, okay, by calculating the number of moles of sugar. We can find its molarity, right? So what happens if we add more water to it? What happened to molarity? Is it going to be more or is it going to come down? What is the answer?
The volume will increase.
Yeah. So volume will increase, so molarity will decrease. So molarity can change with dilution or addition or removal of solvent. Addition or removal of solvent, right? So if you add more water, the volume will increase, the solution will become more dilute, and the molarity will be less. Suppose if you keep a solution in sun, the water will get evaporated and its molarity will increase. Okay, is it clear? So molarity can change with addition or removal of solvent. I hope this is clear to you, right? Next is how to find out the change in molarity when you add water or when you remove water. What is the formula? Can you tell me, Marwa and Ayesha? What formula do we have to use if you add water or if you remove water? How the molarity is going to change? Suppose if the initial molarity is M1 and initial volume is V1. Okay. And when you add water, addition or removal of water. The new molarity is M2, which is unknown. And the new volume is V2. So what is the relationship? And we have added or removed only water but not the solute. Is it clear? By dilution. So what could be the relationship between the initial molarity and initial volume and the final molarity and the final volume if you add or remove just water? Any idea? Marwa and Ayesha, tell me.
So I didn't understand your question.
Suppose what is the formula which correlates the initial molarity and volume with the final molarity and the volume? That formula is, I can explain you, that is M1V1 equals to M2V2. What this M1V1 and M2V2 is? Suppose we have initial molarity, right, Aisha? M1 and
Yes.
initial volume is given Marwa V1 in liters, right? So we can multiply. If we multiply that, we can get the moles. The moles of the solute has remained constant, that we have already seen here. Look. When you multiply the molarity with volume, you get the moles. Okay, because you have added only water, so moles of the solute remain constant. So new moles will also be same as that of original moles. So M1V1 equal to M2V2 is the formula that need to be used when you have initial molarity, initial volume given, and final molarity need to be found out, and you are provided with the final volume, which is you can find out, which you can make out that how much will be the final volume when this much quantity or that much quantity of water is added. They will give you in the question. Let me take an example. Suppose a 2 molar NaOH solution is there.
So the volume is always constant, right?
No, the moles are always constant. volume you can change by adding water or removing water. But
Sir, the equal sign signifies that both are equal. So, does it mean the initial concentration is equal to the final concentration?
no, I will explain. Suppose these are the moles of NaOH. Okay, understand it in the picture. There are two NaOH moles. Okay, NaOH, 2 molar NaOH solution of volume 1 liter. This is 1 liter solution. Got it? 2 moles are represented by 2 stars. Okay, find the molarity if if 4 liter of water is added to the solution. So what is constant? Is the initial concentration and the final concentration are constant, Mara? Or is it the initial moles of NaOH or the final moles of NaOH are constant?
Moles are constant.
Which is constant? The moles of the
Mo-
NaOH are constant, or the volume or the amount or the concentration?
the moles are constant.
Moles are constant, right? And Aisha, is the volume constant?
No, sir. Volume.
Definitely, volume is increasing. Yes, because you are adding now. The final volume has changed to 5 liters, right? So
Yes, sir.
suppose if we have these type of questions in which the solution is there, you add water. Okay, what will be the molarity? Okay, so which formula are you going to apply? You are going to apply M1V1 equal to M2V2. Got it? This
Yes,
is the
sir.
formula you need. Yeah. So M1V1, and how this formula came, that also I will explain, right? Initial molarity is 2 molar. Initial volume is 1
One.
liter. Final modalities need to be found out. Let it be M2. What is the final volume?
1 liter plus 4 liter, which is 5.
Yeah, it will be 5 liters, right? So molarity is going to be 2 by 5 molar. New molarity is going to be 2 by 5, or it is going to be 0.4 molar. How this formula came? Molarity is, this formula came. Molarity just now we have seen is number of mole by volume. So number of mole of solute will be molarity into volume. Okay. So prior to addition of water, the number of mole of NaOH were molarity into volume. And after addition of water, only the volume changed. Okay. So number of moles were same. So after addition of water, the new moles will, you can find out by M2V2. They should be same as that of M1V1. Number of moles of NaOH in the final solution, number of moles of NaOH in the initial solution, number of moles of NaOH you can find out by multiplying molarity with the volume. Is it clear or not? So you can
It is
equate
clear.
both of them, M1V1 equal to M2V2. Okay, so this formula to be applied only when you have what? When you have water being added or removed from the solution. Got it? So I hope this is clear to you. Okay, M1V1 equal to M2V2. Right. Suppose there can be a question in which 1 liter of 2 molar NaOH solution is mixed with, this is a different type of question, okay, not from the above. It is mixed with 2 liters of 4 molar NaOH. So what is changing? Is the moles of NaOH changing? Are the moles of NaOH changing? Is the volume of the solution changing? Or both are changing? One liter, 2 molar NaOH solution. This is one of the solution, which is 1 liter and 2 molar. Okay. It adds some NaOH in it surely because it is 2 molar and 1 liter of it. The other solution is 2 liters and its molarity is 4. Okay, you mix them together and you get a final solution, okay, whose molarity is M3. You don't know it, but you can make out the volume. What will be the volume?
3.
3 liters.
Yeah, 1 plus 2, that because volumes are additive, right? So 3 liters. Okay. So in this we are adding the moles of NaOH also, we are adding the water also. Okay. So if you are having this kind of relationship, when you are mixing two, the molarity is final molarity. Always remember volume M1 V1. Okay, the final volume V1 plus V2 equal to one solution. This is M1 V1 plus M2. You are going to use this relationship. If you are not adding two solutions, just water, M1 V1 equal to M2. Okay, if you are mixing two solutions, means you need to have one more molarity and one more volume. So you are going to use this formula. M into V represent the number of moles, okay, of NaOH from the first solution, number of moles from the NaOH from the second solution. To add them together, divide by total volume. Okay, so the new molarity is going to be M1 V1 is how much? 2. M2 V2 is how much? 6. This is M2 V2, right? This is M1 V2. Okay, divide by total volume, that is 3. Okay, that is going to be 8 by 3 molar. 8 by 3 is how much? 2 point. That is going to be 220. This is clear? Just tell me how much you understood this. You can ask me any number of times, okay? No need to just ask me. Is it clear, Ayesha? Marwa, tell me. Any doubt, anything?
So can we also like find the moles of each solution? Like the in the first solution is like 2 into 1, 2
Yeah,
liter, 2
moles
moles
of
into 1.
yes, exactly. Moles of NaOH. If you try to do it in more basic way, moles, how you can get moles? You can get by molarity into volume, because molarity is moles by volume, you cross multiplied molarity into volume, you get the moles. Yes. So what you are telling, the in the first solution the moles will be
2 moles.
2 moles of NaOH. Yeah, very good. And Marwa, the second solution, the moles of NaOH will be
Uh, 8 moles.
8 moles, right? You add them together, total moles will be,
10 moles.
yeah, 10 moles. I think I made a mistake. M2 into V2, 4 into 2 is 8. Yeah, I made a mistake. I wrote it wrong. Yeah, 10 by 3. Correct. This is wrong. Got it? Because I think instead of 6, I wrote it like this. Okay, 8. Is it clear? So 8 moles, 10 moles by 3, that is going to be 3.33 molar. Is it clear to you?
Yes, sir.
Okay, so you add the total moles, okay, and M1 V1 plus M2 V2. Divide by total volume. Total volume is additive, we know, right? And total moles are also additive. So you get this as the final concentration. Is it clear or not? Got
Yes,
it?
sir.
Yes.
Clear.
Okay. But if you are adding only water, if you are adding only water, then you should, or removing water, just water, not mixing two solutions, just adding or removing water. Then initial moles equal to final. M1 V1 equal to M2 V2. Got it?
Yes, sir.
Next is, yeah, clear? Next
So,
is, next is your mole fraction. Right? What do you mean by mole fraction? And mole fraction is going to be used in uh, Henry's law, which is the first part of the liquid solution chapter, where you study mixing of gases into water or any solution. There you will find the application of mole fraction. It is represented by Greek letter which look like X, that is chi. Got it? So what do you mean by mole fraction?
It is the number of components divided by the total number of components. For example, if there are two mixtures, A and B, then it is written as number of components of A divided by number of components of A plus B.
Yes, in terms of moles. Got it?
Yes.
And Ayesha, suppose if we are having, this is a common part, and fraction always it is going to be less than 1. Got it? And if this we know in the common life, and you must have studied in your junior classes also. But a very good example to represent the fractions. Out of this pizza, if you have this much amount, this is how much? Out of the 4 parts,
1/4.
1/4. So similarly, out of the total moles, how many moles, what fraction of moles are carried by one substance? That is the mole fraction of that substance. Is it clear?
Yes, sir.
Mole fraction, and as Marwa told, of a component, if you have A and B, okay, so and you have moles of A as Na and moles of B as Nb, the mole fraction of A will be the fraction of moles of A, okay, that is moles of A divided by total moles. Total moles are Na plus Nb. Mole fraction of B will be, got it? And suppose if you add all the fractions, what will be the result? Can you tell me?
1.
Yeah. So sum of the mole fraction of all the components should be equal to 1. That you must remember. So mole fraction of A, mole fraction of B. This is just a binary solution. So we are adding the mole fraction of both of them. That will be equal to 1. Suppose, and this saves a lot of our time also. Suppose in case if we find the mole fraction of any one component, we can get the mole fraction of another component by subtracting it from 1. So just keep in mind. But if you have 3 components, then you need to add 3 mole fractions to get 1. You need to add the mole fraction of all the components. Got it? Then only
Yes.
you are going to get 1. Okay. So mole fraction, let's do one question. Suppose if I take 2 grams of hydrogen gas, and if we add 4 grams of helium, what will be the mole fraction of hydrogen and what will be the mole fraction of helium? First you need to find the moles. Got it? Then only you can find the mole fraction. Is it clear or not?
Yes.
So don't go directly for the mole fraction. First get the moles. So hydrogen, the molar mass is how much? It is 2. Got it? So moles are given mass by molar mass. So you have taken 1 mole of H2. Similarly for helium, how many moles? Marwa and Ayesha, tell me. Helium, the molar mass is 4.
4.
So how many moles? Thus we have taken 4
1
moles.
mole.
1 mole of H. Got it? So mole fraction. Now we can get back to our mole fraction. Mole fraction of hydrogen will be number of moles of hydrogen divided by total moles of all the substances. Is it clear? That is going to be 1 plus 1. Right. And thus you can figure out very easily that both are having 1 mole each. Right. So the fraction will be half. This is going to be half, and the mole fraction of helium is again going to be half, right?
Yes.
In HE. So just I took very few examples. So as we will have more classes, so we can cover more topics, more examples, right? I hope you understood this one. Any doubts in this mole fraction part?
No, sir.
So, but this is also half equal mole fractions. Mole fractions, where it will be used? They are used to find out the pressure, partial pressure of the compound. Suppose in the atmosphere, we are having oxygen and we are having nitrogen. Total pressure is 1 atmosphere. And if I multiply the total pressure by mole fraction of a gas, I will get the partial pressure of that gas. That will be useful in the next topic, okay? Henry's law. So we can cover it. So let me end the class. Okay, I hope everybody understood this.